Welcome back to part 2 of Module 7, Lesson 1, where we're solving two-step equations. They're starting off this one by comparing arithmetic to algebraic approaches to solving problems. If all you use is numbers to solve the problems, well, that's going to be your arithmetic approach. However, if you stick a variable in it, then you suddenly change from the world of arithmetic to algebraic. For example, Natalie is participating in a jogathon. Her goal is to raise $125. She has collected $80 and will receive $3 for each lap around the track she jogs. How many laps does she need to jog in order to reach her goal? Well, if you were to do the arithmetic method, what you would do is you say that she had $125 that was her goal. You'd subtract the $80 from it that she's already collected, and that would mean she'd have $45 left. And from there, you would take that $3 for every lap, so you divide that into the 45 and find out that she had a total of 15 laps that she needed. And when you were in elementary school, that is exactly how you solve these. You use the arithmetic approach where you kind of piecemealed it together and came up with an answer. But now we're big kids, and being big kids, we have to use the algebraic method on a lot of what we do. So for the algebraic method, they said, well, the goal was $125, and they set that equal to the $80 she earned plus 3 times the number of laps that she had to make. From there, they isolated the variable by subtracting 80 from both sides, and that gave them the same 45, and now it's set up equal to 3 times the number of laps. They divide 3 on both sides, the 3's on the right divided out, and what do you know? She gets the same 15 laps either way she does it. Now I know in your mind that's a lot more work, and it is. But it's also what I'm going to expect to see on both the homework and the test. If you do this, you do these problems using the arithmetic method and the instructions don't specifically say to do that, I'm not going to give you credit for it. You have to do the big kid algebraic math to earn credit for these problems. Our new inquiry question says, how can a bar diagram help you to solve problems involving two-step equations? Well, let's find out. Miranda bought 2 large postcards and 4 small postcards at a souvenir shop. Each small postcard cost 50 cents. If Miranda spent a total of $5 on postcards, what is the total cost for the 1 large postcard? Be able to explain the strategy you use to solve this problem. Moving on from there, we want to know how could you use a bar diagram to find the cost of your 1 large postcard. We're going to draw a bar diagram and be prepared to explain it. Now what do we know? We know she bought 2 large postcards. We also know she bought 4 small postcards, and I'm going to go here and say that the total of those is going to be $5. Okay? We also know that each of the small postcards costs 50 cents a piece. And with that, we have the information we need to put together our bar diagram. So your whole bar, that represents the $5 right there. $5 is going to be your whole bar. And then we're going to break it down from there. You've got 2 large postcards and 4 small postcards. What do we know about these small postcards? Well, we know that each one of those small postcards costs 50 cents each, which you see right here. You can see they put the $5 in there. So we have 50, $1, $1.50, $2. 2 of the $5 is going to be for the small postcards, and that means that your large postcards, that's going to be 2 divided into $3 that are left over. Continuing working through the problem, they want us to write up something on how to solve it. So what would I do? I would say that I use the bar diagram to find the total amount spent on small postcards and then subtracted the total amount, or that amount, from the total cost. From there, I then divided the remaining amount by the 2 large postcards to find out that they cost $1.50 each. That would be a good explanation of how I would work that problem using the bar diagram. Now we could also create an equation based off this information. First, I have 2 large postcards, 2's going to go right there, plus $2 for the small postcards, because remember we added 50, $1, $1.50, $2, and that equaled a total of $5. And by doing that, we came up with an equation that we could solve algebraically. Of course, in the end, the final cost is still going to be that same, whoops, too many numbers there, $1.50, and it checks. And how does solving the problem using a bar diagram compare to solving an equation? For me, using an equation is going to be a whole lot easier. And now it is time for us to start getting into some word problems, because the title of this lesson is to write and solve two-step equations. So now we're going to have to start writing some. Some real-world situations can be modeled by two-step equations. Consider the following problem. A caterer is preparing a dinner for a party. She charges an initial fee of $16. That's $16 she charges just for the privilege of doing business with her. After that, she charges $8.25 per person. How many people can attend the dinner that costs $131.50? And to do this, we're going to take and select some cards here, figure out what it's saying. First, you have an initial fee. That initial fee was what? That initial fee was going to be your $16. You also had $8.25 per person right there. I'm going to take and make that one blue. And then from the $8.55 or 25 cents per person, all that adds up to a total cost of $130.50. Looking at defining our variable, they said let P represent the number of people that we're going to be eating there, and then convert that into an algebraic expression. You have your $16 initial fee plus your $8.25 times your number of people, and that's going to equal your total. Now, fortunately for us, they didn't want us to actually solve that problem. They just wanted us to see how to lay it out. And now we're going to do example 3, where we're going to lay out another one, but this time we get to see it all the way to the finish line. Toya had a birthday party at the movies. It cost $27 for pizza. So that is a one-time fee that can cover everybody. It also costs $8.50 per friend. So you're going to take every friend that she takes and multiply that number of friends times $8.50, and then find out how many friends she could take if she spent a total of $78. Well, let's take and set up our equation. First off, we're going to look at our cards again, just like we did before, where the cost of the pizza plus the cost per friend times the number of friends is equal to $78. Defining the variable, they let n represent the number of friends, and from there we're going to use a bar diagram and say that the pizza, which was $28, plus the $8.50 times the number of friends is equal to $78. Now, I'm not going to ask you to use a bar diagram in your homework unless the assignment specifically says to do that. Instead, I'm going to expect you to go straight to the equation, which says the $27, you see that right here for the pizza, plus $8.50 times the number of friends, that's this part of your bar diagram right here, equals the total of $78 that you see in the bar diagram right here. Now it's time for us to solve our equation. And in doing that, we're going to go and look at it and find out what's being added or subtracted from our variable and what's being multiplied and divided from our variable. Your $8.50 is being multiplied and divided, so we're not worried about that, but the addition is going to be the 27. Now remember, it's not because of this plus sign here, it's because of the invisible plus sign here that we're adding 27. And since it's plus 27, I'm going to start off by subtracting 27 from both sides. The 27's on the left, they're going to zero each other out, leaving $8.50 in coming straight down. And then 78 minus 27, that's going to leave me with 51. Now we're going to undo multiplication and division by dividing 850 on both sides. And when you do that, the 850s on the left divide each other out. And on the other side, we're going to do 51 divided by 850. And we're going to go ahead and save some time on this one and jump up to a calculator to solve it. So I have 51 divided by 8.5. And that means that she can have 6 friends go to the movie with her. And what does that mean? Once again, Toya had 6 friends at her party. Easy math. Now we're on extra example 3, and this one's all about you. You want to solve this problem involving Cameron, and after you find out what your equation's going to be, then you're going to solve it to find out just how many movies he can download. Go ahead and work this problem on your own and check your answers. So when I look at it, first thing I'm going to notice is that he wants to download some movies, and that each one of those movies cost $14.50. But that is some movies, so I'm going to let M equal to my movies, and I'm going to say that just for starters, we've got $14.50 times some number of movies. But he also wants an ebook. That's one ebook, and one ebook costs a total of $22.50. Finally, write and solve an equation to find out how many movies he can download. Oh, kind of lost part of our problem here, so what's it say there? He has a total of $66 to spend, so we're going to set this up to be equal to $66. I'm going to start off by undoing addition and subtraction, subtracting my $22.50 from both sides, annexing my zeros as needed, and wait, I do want to go back and make sure I've got a good equation here. So I've got 1450 plus 22.5 equals 66. That's the answer I came up with, and they agree with it, or the equation I came up with. Now we're going to take and simplify this out. Those zeroed out, leaving me $14.50 times some number of movies is going to equal to, and when I subtract, I'm going to get a 0. That's going to become a 10 and a 5. That's going to become a 3 and a 4. So we got $43.50 left to spend on the movies. We're going to take and divide $14.50 on both sides. And when we do that, I'm sorry, I subtracted. I should be dividing those, so let's try that again. We're going to divide by $14.50 on both sides. And when I do that, these are going to divide out, becoming 1. 1 times M is M. And then 43.5 divided by 14.5 equals 3 movies. So he can download a total of 3 movies. We're going to plug that in right here and hit our check, and our answer checks. Easy math. Example 4 is going to give us the same general kind of problem, only now we have some mixed numbers involved in it. It says that Diego's aquarium contains 30½ gallons water. He drains water at a rate of 5 gallons per minute. Write and solve an equation to determine how many minutes the amount of water will reach 10½ gallons. Now this one's a little tricky in how they have it worded, so we're really going to need to think about what it is they're going to say here. In words, they say that 30½ gallons plus 5 minutes per gallon equals 10½ I'm sorry, not plus, minus, that's a minus right there, minus 5 gallons per minute equals 10½ gallons. We're going to let M represent what? The number of minutes that we're going to be draining that tank, because every minute it drops 5 gallons. So from there, your equation is going to be 30½ minus 5 times some number of minutes is going to equal to 10½. Check it. That checks. And now we're going to move on to the next part. Part B says to solve the equation. And they have done horrible things here again. They've subtracted them vertically. I can't stand subtracting fractions vertically, so we're going to take and set this up and do it horizontally. Now sometimes it's a huge benefit to convert our fractions to or mixed numbers to improper fractions, but not this time. This time, actually, yeah, this time will be a huge benefit, and I'm going to show you why. So we're going to start off by undoing addition and subtraction, and by subtracting this plus 30 and 1/2 on both sides. So I get 30 and 1/2 minus 30 and 1/2 minus 5m equals 10 and 1/2 minus my 30 and 1/2. And when I do that, these 30 halves, they just divided or subtracted each other out, being 0, leaving a negative 5m on the right hand side. On the left hand side, excuse me. On the right hand side, we got a bigger issue here. I am subtracting a smaller number by a larger number, which means that it's not going to be something, particularly with mixed numbers and fractions and everything involved here, I don't want to try and do that and not convert them to improper fractions. So I'll do improper fraction, 2 times 10, that's going to be 20, plus 1, that's going to become 21 over 2, minus 2 times 30 is going to be 60, plus 1 is going to be 61 over 2. Now I have my least common denominator, which means I'm going to take 61 or 21 minus 61. Signs are different. Find the difference with your sign in front of your larger number going in front of your answer, and of course your denominator stays the same. Now I can simplify 40 divided by 2. That's going to give me a negative 5m is equal to a negative 20. Negative 40 divided by 2 is negative 20. Final, we're going to take and divide both sides by that negative 5. When we do that, the negatives divide out on both sides. On the left, 5 divided by 5 is 1. 1 times m is m. And 20 divided by 5, that's going to equal 4. So the final answer is it will take 4 minutes for the aquarium to reach that time. Now when they did it vertically, but in the end they still got negative 5m here. And they ended up getting, well, that would be a negative 20, which is what I got, but they didn't change them to mixed or improper fractions, and you know that just gets brutal. And their final answer, m, is going to equal to 3, is going to be the same thing. Oh, did I get 3 or I got 4? I got 4. M is going to equal to 4, is going to be the same thing that I got. Once again, it's going to be your turn to solve the equation, or create an equation, and then solve it. Be sure to pause your video while you're working on this, please. Alright, let's take a look at this. Our current temperature, that's going to be 84 degrees Fahrenheit. So I'm going to take right here, 84 degrees is the current temperature, that's our starting number, and then it is expected to drop 2.5 degrees every hour. That's minus 2.5 times some number of hours. And they want to know how long is it going to take for the temperature H to be equal to 54 degrees. From here we're going to just treat it like any other two-step equation. We're going to undo addition and subtraction first by subtracting 84 from both sides. When you do that, your 84 zero out, leaving you a negative 2.5h is going to equal to a negative 30. Signs are different. Find the difference. Sign in front of your larger number goes in front of the answer. After you do that, now it's time to divide both sides by the negative 2.5. And of course, the negatives are going to divide out on both of them. The 2.5's become 1. 1 times h is h. And let's see here. 2.5 goes into 10 4 times, 20 8 times, 30 12 times. So 12 will be our final answer. And you can see, actually I've already cleared out the screen where I'd worked it earlier, but forgot to push the record button. But my equation is the same exact equation they came up with, and my answer is the same exact answer they came up with. Now, you guys get busy working on your homework. Make sure you are giving me good, big kid algebraic problem work just like I've been giving you. I don't want to be seeing that arithmetic approach that you all used in elementary school. You're big kids now. You've got to use the big kid method to solving these problems. I look forward to seeing your work and answering any questions you have in class tomorrow.